Hello everyone, Romulo Lollato, K-State Extension Wheat and Forage Specialist, and today we're going to give you a little research update of what we learned during the 2020 winter wheat growing season. So as you know, we have several research projects all over the state, from here in Manhattan all the way to Sumner County, all the way to Wichita County in western Kansas, and we run several variety by management type of trials. And one that I want to talk to you in particular today is a big trial that we ran in 4 locations this year to try to understand how different varieties respond to nitrogen rate. So we actually had a trial with 14 winter wheat varieties that are well adapted to central Kansas, and we ran this trial in 4 locations, right? And we were exposing those varieties to either 0, 40, 80 or 120 pounds of nitrogen per acre. Now, whenever we counted with the amount of nitrogen in the soil at planting, right, they ranged from about 25 pounds of nitrogen per acre in the 3-feet profile, all the way to about 170 units of nitrogen in the soil at planting. You can already imagine that we had quite different responses, right? In fact, when we look at the entire data, our yields ranged anywhere from about 20 bushels per acre, averaging 50, all the way to about 90 bushels per acre across all of these trials. What was the effect of nitrogen? In fact, we can divide all of this data that we collected in 2 big type of environments. One, high yielding environments that maximize yields at about 70 or 80 bushel per acre. With that increasing nitrogen rates, there was an increasing yield as well, but then a plateau in most of the varieties. And then a lower yielding environment where yields increased as well up to a certain point, but then yields maximize about 50 bushels per acre or so. Okay, so did varieties differ in the break point in which they maximize their yield? And the answer to that is that in the low yielding environments, we needed in between 100 and 110 pounds of nitrogen per acre total available for varieties to maximize yield at about 50 bushels per acre. And in the high yielding environment, we needed almost double of that. We needed in between 200 and 220 pounds of nitrogen per acre available in the season for varieties to maximize between 70 and 80 pounds or bushel per acre. Now the question is, are varieties that are yielding more because they are uptaking more nitrogen or not? And what we found was very interesting as well is that no, the varieties that were yielding 65 bushel per acre, they were actually maximizing yields at the same nitrogen available as those that were maximizing yields at 85. So the 20 bushel per acre difference tells us that there are differences in nitrogen use efficiency among these varieties, some of them being able to use the nitrogen much more readily than others. But not only that, they're likely a protein premium as well. If one variety is producing the same amount of, with the same amount of nitrogen, 20 bushels per acre more, that means that probably something is lacking, and that's likely protein. We're going to measure protein in all these trials and get back with updated results soon.